Hey class, and welcome back to lab number 7, where we're going to be looking at torque equilibrium, and a little bit of rotational inertia as well. This lab actually has 4 parts, which sounds like a lot, but 2 of them are really more experiential and rather brief. So let me kind of walk you through the lab and give you some examples of some of the tools that I'm going to be using to do the lab. All right, so first of all, there's pre-lab questions. Make sure you answer those. These ones here, number 3 and 4, can be a little bit tricky because it's asking you to solve for the location of the pivot. So it's asking you to solve for this location, the physical location on your meter stick here. So it's not saying solve for R1 or R2, although those will affect it, but instead, what X value on the meter stick would you need to place the pivot under in order for that to balance? It's tricky. It's a little different than you might think at first. So part A is pretty straightforward. All you need is a door. All right, so you're going to apply a force to a door. You're going to open a door in kind of different ways, pushing it at different locations and angles to kind of get an experience with how torque affects or how a torque is generated, and we look at its effects on a door as you try to open it. Okay, parts B and C are a little bit similar to one another. All right, you're going to be creating your balance, like a torque balance situation, initially just balancing things like in that last picture. And then later on, you're going to be using one of your force gauges to actually measure the force on the opposite side to generate the restoring torque for you all. Oh, look, I don't know if you guys can see, but Gus came to say hi. Hey, Bob, you excited for lab? I know, it's so much fun, isn't it? So anyway, here you can see them in bigger mode. All right, so I'm going to talk to you about part B first. So in order to do part B, you're going to need some sort of a pivot location to create your balance. I went ahead and found my trusty drill here, impact drill, because it's rounded. And so the point of contact, when I go and balance, let's say, my meter stick on here, the point of contact is pretty much just one point. If it's not perfectly balanced, it's going to start to rotate one way or the other. So I'm first asked to experimentally find the center of mass. So I'll just kind of balance it so that it's even. And then the very central line, and this is nice because my drill even has a little line here that will show me exactly where on my meter stick it is. You might not have a meter stick, and that's fine. When I've done this lab in the past, I actually found like a bamboo stick we use for gardening, and I used that. You can even use a ruler if you want to. It's a little bit smaller, so it doesn't give you quite as much many options, but it will work as well. Okay, kind of whatever you want. So you're going to balance this guy first, and then you're going to be basically testing those pre-lab questions I just talked about. Once you know where the center of mass is, you know that that's the point at which the weight of your meter stick is pushing down all of the time. So you're going to want to try to get an approximate value for the weight of your meter stick. Again, that's a little bit tricky with our tools, but I know most of you have these little force measurers, so you can somehow, tape or even just balance in here the meter stick, and you should be able to get a reasonable value for the mass of the meter stick. So if I kind of get this balanced in here, see how well this is going? When it's balanced, it looks like my meter stick here has a mass of right around 80 grams. It's a little hard to tell. You might want to like tape it in there, or even just, get a little piece of tape and tape it vertically like this. That might be even easier. So I could like take my binder clip here and just clip it on. So now I can really get a more accurate measurement. The problem here is, right, it's measuring the mass of my binder clip as well. So if that's the case, then I might need to put my binder clip at the very middle and make it part of my overall mass. And I then go to balance. But putting it at the very center so that I know the center of mass is still the same. Okay, so that's that. And then you're going to be hanging masses on here. So for hanging of masses, what I did was I just grabbed a rubber band. I can kind of loop my rubber band around here a few times. And I'm going to loop it at a certain location. So let's say I want to put it at like the 5 centimeter mark on my meter stick, so I know the physical location. So it'll be really easy to measure my R1 and R2 from those pictures. And then you can take and just hang a mass from here, like so. And then you're going to be balancing this guy again. and you're going to be finding where the pivot location is and trying to calculate it as well based on this mass, its location, the mass of the meter stick, and its center of mass as well. Okay, so there we go. Got it balanced. I know where this is at. I know where my pivot experimental value comes in, and I should be good to go. If you don't have masses like this, right, you can also do like we've done in the past. Here's just a little cup. I can put it on here, and then I have random nuts and bolts from the garage, and so you can take these and put them in here, and then do the same game. Now it's lighter, right? It's going to be a different balance location. And I'm going to want you to do various trials. I can tell you to do 9 to 12 trials. So maybe you'll do this mass, try it at a couple different locations. Notice the balance point changes. Change the mass, try that at a couple new locations, and so on. So you're going to do that initially, and then later on you're going to be asked to have 2 masses, one on either side. So then you'll hang another mass from the opposite side, and so then you'll be kind of doing the same thing, now with 2 different masses on here at different locations and trying to balance it. All right, so again, you're going to be, based on where these are at, you're going to be calculating and predicting, making a hypothesis for where this pivot location should be, okay? So one thing that's a little different here, now that we've been doing these labs for a while, if you notice, there's no data tables here for this part. In fact, I ask you specifically, as you can see right here, create your own data tables. All right, I want you to look through the lab and make up your own data tables. One for kind of this step 3 and another one for this step 4. So you're going to have to build your own data tables 2 and 3. And I already kind of told you in the post lab that that's what you're doing. Okay, so that's the first part, or the second part. The first part's the door, part B is that. Part C is actually very similar to what we just did, only now we're going to be measuring the force. We're going to be calculating and measuring torque and forces. So again, you can either do it with a meter stick. In the picture, I show you that there's a pencil. I actually find it's just as easy to do it with your same kind of pivot point that you did before. So you can do the meter stick. Because my screen's not zoomed out enough, I'm going to switch to my ruler so you can see it easily. But what you're going to be doing here is a similar kind of idea. You're going to be taking a mass and putting it on one side, or really for safety's sake, I would say maybe hang it on one side. And you can choose where to hang it. You can hang it here, you can hang it here, you can do a couple different trials at different spots. But you hang it at some location, and then you're going to then place the pivot. Now you choose the pivot. So let's say I hang this at the 4 centimeter mark, and I'm going to put my pivot at the 12 centimeter mark. This is generating a certain torque, so I should be able to predict exactly how much force I need to exert on the other side, whether it's here, 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 or here. So let's say, I did the calculation. This is generating a certain torque here. If you move to using like a ruler, you can pretty much ignore the weight of the ruler because it's so small, as long as you don't use really small masses. And then you can go ahead and test. And you might need to adjust things so you're hanging off the edge. But then you just put your force sensor at the physical spot that you said you're going to do your measurement at. And you hold down, and you can actually measure now on the force sensor how much force is required to keep this in equilibrium. It's really cool. So there's one trial right there. I can then move this. If I move it closer, I'm decreasing my lever arm distance. So in theory, now I'm going to need a larger force to keep it in equilibrium. And I can check and see, yep, sure enough, it's a larger force. Okay, well, what would happen if I stayed there and moved this guy out further? Once again, I'm going to need a larger force now because that's at a new spot. And so I can do the same thing again, and you can see there's a new force. And then you might even want to take this and replace it. Hey, what would happen, let's say, if we, doubled the amount of weight on here? So I took this, and instead of having just one, I hung 2 of these same amounts of masses on here. You want to try to get them as close to the same spot, or you can have them in different spots. I guess you still can do the calculation the same. Put this guy back out here and see how much force is required to keep it in equilibrium. Just be careful. If this slips off, things are flying, you're creating basically a little catapult, all right? So be careful and be safe with that. But you can see, again, if you look here, there's a data table now. I'm only making you create your own for the one. But it tells you, right, you're going to be doing 6 different trials. It's telling you to do it with 3 different masses at 2 different locations each, right? So that gives you a total of 6 trials. If you want to make it 9 by changing the location of this guy, you can do that as well. So that's that part. And then the very last one, part D, is really just an experiment with rotational inertia. So you can go back again to having something like your meter stick or a ruler, that's fine. But what you're asked to do here is to put masses on this guy at different locations. So let's say, I have 100 grams here. So I can put 100 grams on each end, but you're going to want to affix it because you're going to be like wiggling this around. So again, I got my binder clips. So maybe I'll try to clip the masses on. My binder clip is big enough, so I'll move to this guy. Clip that on. I only have one big binder clip, so maybe I'll use my rubber band on the other side to try to stick this on here really quick. So again, you want some way to fix this. You could just tape it as well, but apparently I didn't get out the tape for this lab, so this is what I get. It's half the fun, in my opinion, is just getting to be creative with labs this semester, trying to figure out how to do them ourselves and using our stuff at home because physics is everywhere. So. All right, so there we go. So I got my different masses, and what you're going to do is you're going to hold your meter stick, and you're just going to, again, this is an experiential one. Feel how much resistance is there to motion. How hard is it to spin this back and forth? It's not too bad. Might help to even do bigger masses. Maybe you do 200 grams or 300 grams or 400. It doesn't have to be exact, but you kind of get the feel of what it feels like to do this. Then I ask you to reduce the mass, and so you might take these off and replace it with 50s instead, or some smaller amount. It doesn't have to be exactly half. Again, feel what it feels like. I ask you to move them. So if you move them in half the distance away from the center, now what does it feel like? Is it easier or harder? Why do you think? Then I ask you, at this shorter distance, how much more mass would you have to add to get it back to the same difficulty as when you had the masses out here? Experimentally try and test that idea as well. Here's one where you could hang masses instead. Just put a little piece of tape on here so that as you swing it back and forth, it's not going to be sliding off the end. So hanging masses could work here as well. Okay, so you'll see there's a data table just walking you through, and the instructions explain, but there's a series of 5 different distributions I want you to try out, and then there's some discussion questions as you think about what you're changing, what the effects are, why, and so on. So that's lab number 7. Let me know if you have any questions, and have, as always, the mandatory fun that is physics lab.